All right, let's talk about something that feels super obvious, but actually has a twist that's stumped people for ages. We're diving into the physics of free fall.
Okay, to kick things off, let's do a little thought experiment. Picture this. You're at the very top of a skyscraper. You've got a heavy bowling ball in one hand and a super light feather in the other. You let them both go at the exact same moment. So, which one lands first?
I'm guessing you have an answer in your head already, right? It seems totally obvious. But here's the cool part. What seems like such a simple question is actually one of the most classic puzzles in the entire world of physics. I mean, everything we see in our everyday lives, watching leaves flutter down versus a rock just plopping to the ground, it gives us a pretty clear answer. But is our gut instinct really right? Or does physics have a totally different answer? Well, that's exactly what we're going to find out. So, to get to the truth, we kind of have to step into the perfect, clean world of physics for a minute. Let's lay out the basic rules of what freefall really is. So, what does freefall actually mean? Well, the official definition is right here. It's when an object is moving and the only thing pulling on it is gravity. And trust me, that word only is the key to this entire puzzle. And that one idea really boils down to two simple rules. Rule 1, for true freefall, you can't have any air getting in the way. So you have to pretend we're in a total vacuum. Rule 2, and this one is a big deal. The speed up, or acceleration as it falls, is always the same. It's constant. Okay, so what do we mean by constant acceleration? This is where we get to the real secret sauce. Gravity's steady, nonstop pull on everything around here. And it actually has a number, a super famous one in physics. Negative 9.8 meters per second squared. We just call it G. Think of it as the engine that makes all of this happen. But what does that number even mean? It's not just some random value. It's telling us how much faster an object gets. Basically, for a falling object, its speed gets a boost of 9.8 meters per second.
For every single second it falls, it's like a constant speed up. And here's the mind-blowing part. This applies to every single object in freefall, no matter how heavy or light it is.
All right, that makes sense for things falling down. But what about things going up? Well, because gravity's pull never stops, it affects things on their upward journey too. Let's check out another example. Think about throwing a ball straight up. As it's going up, it's moving fast, but gravity is already working against it, slowing it down. Then for just an instant, at the very top, it stops. Its speed is 0. But is gravity gone? Nope, it's still pulling down. And then, of course, on the way down, both its speed and gravity are pointing in the same direction, so it just gets faster and faster. And that right there is maybe the most surprising part of all this. Even when the ball is perfectly still at the top, gravity is not taking a break. It's still pulling down with that exact same force, that same negative 9.8 meters per second squared. Okay, so now we've got the pieces. We know that in a world with no air, gravity pulls on everything the exact same way. So let's head back to that skyscraper and finally solve this thing. So, the bowling ball and the feather. Knowing what we know now, what happens? Okay, here's the big reveal, side by side. In our world, the real world with air, your gut was right. The air pushes up on that feather, it acts like a little parachute and slows it way, way down. But in the world of physics, in a vacuum where there's no air at all, well, then there's only one thing acting on both of them, gravity. And that means they speed up at the exact same rate. They fall together side by side and hit the ground at the exact same time. So, what's the big takeaway here? The huge misconception we all kind of grow up with is that how heavy something is determines how fast it falls. But, as we just saw, physics tells us that's just not true. It was never about weight. It was always about the air. The only reason a bowling ball beats a feather in a race to the ground here on Earth is air resistance. And that's it. Kind of makes you wonder, right? What else do we think we know just from what we see every day that physics explains in a totally different way?